In this video, let's try to solve exam questions on matrices and determinant from past paper. The first question, if the matrices, what you see here, there are two matrices which are 2 by 2, they are inverse each other, and then which one of the following is the possible values of x? If two matrices are inverse each other, like A times A inverse, obviously will give us the identity. So if you consider the first matrix as A, the second one will be A inverse. They are inverse of each other already. So I'm going to multiply, and the product has to be the identity. The identity matrix for 2 by 2 is 1 0 0 1. So let's write the two matrices side by side. 3 x plus 2 and x 3. This is the first matrix, and the second one x plus 1, negative 4, negative x, and x plus 1 is equal to 1 0 0 1. Then how to multiply? The first row obviously will multiply the first column here. So the 3 will multiply x plus 1, which will be 3x plus 3 when I multiply the 3 with x plus 1. And the same way x plus 2 will multiply negative x. So it will be negative x square minus 2x. This is going to be the first entry of the product. This must be equal to the first entry of the right side, which is 1. I don't have to multiply each and everything because that's enough. It has only one variable. This equation is enough to get the x. I multiply the first row with the first column. That's going to be the first entry. It is necessarily equal to the first entry of the right side. Then when you reshuffle and rearrange, this equation will give us negative x square minus, plus x, because 3x minus 2x will be just x. Then this one will come and subtracted. It will be plus 2 is equal to 0. And then if I multiply each of them by negative, x square negative x minus 2 is equal to 0. Then think of two number product, negative 2 and some negative 1. These numbers are x minus 2 and x plus 1. 1 times negative 2 will be negative 2, and 1 plus negative 2 is negative 1. So the two numbers which are giving us product negative 2 and some negative 1 are negative 2 and 1. Therefore, what does this mean? X is equal to 2 or x is equal to negative 1. So the answer should be either of the two. In the choice, which one is found? X is equal to 2, so it's A. The second question, if A equals to 2713 and B inverse is also given, and what is asked here? A times B the whole inverse. AB the whole inverse. This is the same as B inverse times A inverse. It's like that of AB the whole transpose is equal to B transpose times A transpose. So AB the whole inverse means B inverse times A inverse. But we know, or given that B inverse, we don't know A inverse. Let's find A inverse. The A is given already. So the A is equal to, it's given. To use the space, the A is 27 and 13. So when you are trying to find the A inverse, what to do? First 1 over the determinant of A, that is 2 times 3 6, and 1 times 7 is 7. So 6 minus 7 is negative 1. Multiply the adjoint of this 2 by 2 matrix. I will exchange the main diagonal place. 3 2. To find 2 by 2 matrix determinant, first you have to change the place of the main diagonal. This is the main diagonal. Exchange the place, and then negate the other diagonal. Negative 7, negative 1. Multiplied with 1 over the determinant, which is negative. So this 1 over negative 1 means negative 1. So when you multiply, it's going to be negative 3, 7, 1, negative 2. Because negative 1 times 3 is negative. Again, negative 1 times, because 1 over negative 1 means it's negative 1. So negative 1 will multiply each of them. This is the A inverse. Therefore, AB, the whole inverse, is equal to, we said already, B inverse A inverse. The B inverse is given 1 1 0 2. And the A inverse, we got it, negative 3 7 1 negative 2. Then let's multiply. When you multiply, obviously the first row will multiply the first column. So 1 times negative 3, and 1 times 1 with 1 plus 1. The same way for the second column, 1 times 7 7, and 1 times negative 2 is negative 2, and 0 times 3 is 0, and 2 times 1 will be 2. Again, 0 times 7 is 0, and 2 times negative 2 is negative 4. Therefore, finally, negative 3 plus 1 is negative 2, 5, 2, negative 4. So the answer will be, obviously it must be B, but there should be negative here. Okay, next question. If the 3 by 3 matrix, what we see here, if it is singular matrix, singular means, you know, it has no inverse. A given matrix has no inverse means necessarily the determinant has to be 0. So we can say, let this matrix be A. So since it is singular, determinant of A necessarily has to be 0. So let us deal on the determinant. The determinant of this matrix, let's do it. You know how to find determinant. The first row, select the first row and plus, minus a cofactor, the sign, and plus. And then the first entry is 2 plus x times, when you omit the first row and the first column in the first row, what remain? Negative 1, 2, 1, negative 5, then minus 3, cancel the second column in the first row, what remain? 1x, 2, negative 5, then plus 4, the last column in the first row will be cancelled, 1, negative 1, and x 1 remain. Therefore 2 plus x, which is equal to 0, 2 plus x will be multiplied with 5 minus 2 will be 3. I have to do this one diagonally, and minus 3 times negative 5 minus 2x, and then plus 4. Again here 1 minus negative x will be 1 plus x, which is equal to 0. So let us finish it. This means 6 plus 3x, 3 will multiply each of them, plus 15 plus 6x plus 4 plus 4x, which is equal to 0. Then let us add the like terms, which is going to be 3x plus 6x, 9x, plus 4x is 13x, and the constant 6 plus 15, 21, plus 4, 25, plus 25, which is equal to 0. From here, when we reshuffle, 13x is equal to negative 25, then divide by 13 both sides, and the x value will be negative 25 over 13. The answer will be B. Next question. Again here there are two 3 by 3 matrix. Their determinant is already equals. The determinant of the two matrix equal. Then what is the value of x, it says. So again we have to find the determinant of each. For the first one, negative 1 times, you know, when I take the first entry here, I will cancel first column and first row, what remain? The rest. So 2 times 1, you know, 2, minus 4x. Better to apply directly. Okay, then minus 1 in bracket. I'm going to cancel the second column in the first row. What remains? 3 times 1, 3, minus, and 2 times x will be 2x, plus 2 times, again the last column and first row will be cancelled, then 3 times 4 will be 12, minus, and 2 times 2 is 4. This is equal to the next one. Okay, when I go to the next now, again I will take negative x, then in bracket I'll cancel first row, first column and first row. 2 times negative 2 is negative 4, minus, you know, there is minus here, and negative 1 times 3, negative 3, which is plus 3. Then negative of, I will cancel now here, this is the second column and first row, negative 3 times 2 times negative 2 is negative 4, minus 3, 1 times 3, and at last plus 2 in bracket. I'm going to take the last entry of the first row, then what left, 2 times negative 1 is negative 2 minus, and 1 times 2 will be 2. Okay, now let us try to simplify. This negative will multiply each of them. So negative 2 plus 4x minus 3 plus 2x plus 24 minus 8 is equal to 4x minus 3x plus 12. Actually we can finish this one. Negative 7 times negative 3 is plus 21. Here also it's negative 4 times 2 will be negative 8. Okay, then let us collect and add the like terms to the right side. What are they? 4x, 2x, which is 6x, and the constant negative 2, negative 3, negative 5, and negative 5 and negative 8 is negative 13, minus 24 is 11. Negative 13 plus 24 is 11. And the other side, 4x minus 3x is x, and 21 minus 8 will be 13. And then therefore when you finish it, the x will be shifted to the left side, 5x remain, and the 11 will go there, 2, then divided by 5 both sides, the x value will be 2 over 5. So the answer should be 2 over 5. It must be positive, and it's B. Yeah, this is the process, and this is the right way. Okay, next one. It says if A is a square matrix of order 3 and determinant of A given 5, then what is the value of the determinant of A times adjoint of A? Remember, determinant of A times B, when you have two matrices, it is the same as determinant of A times determinant of B. That's rule. So that determinant of A times adjoint of A means it is the same as, instead of saying determinant here, better to put in the absolute value, this is the same as determinant of A times determinant of adjoint of A. We know determinant of A given. Our focus must be on determinant of adjoint of A. What is the rule here? So to find determinant of adjoint of A, the rule says the determinant of any matrix A, I mean the adjoint of any matrix A, is the same as the determinant of A, the whole power of n minus 1. The n is the order of the matrix. This is the formula. So we can get the determinant of adjoint of A from here, and then we can apply. Okay, let us use the space properly. So the determinant of A times adjoint of A is equal to determinant of A times determinant of adjoint of A. So according to the rule, the determinant of adjoint of A is equal to the determinant of A times the power of n minus 1, which is the determinant of A is already given, that is 5, the whole the power of 3 minus 1, which is 5 the power of 2, that is 25. This is the determinant of adjoint of A. Therefore what we are looking for here, it is the determinant of A is given 5, multiply with the adjoint of A is 25. It is 25 here. When you multiply, it's going to be 125. So the answer is A. Next question. It says if the matrix A given, what will be the determinant of, again here, A transpose times A? The determinant of A transpose times A. This is the same as the determinant of A transpose times the determinant of A. And you need to remember, determinant of A is equal to determinant of A transpose. So let's find determinant of A first. The determinant of A is equal to, let us choose the first row as we did before, and the first entry is 3 times. I will cancel first row and first column. 6 times 5, 30, minus 4 times 7 is 28. Again minus the second entry. The second entry is negative 2, so negative of negative will be plus 2, and cancel second column and first row. 0 times 5 is 0, and everything is 0 here. You can ignore. then plus the last entry, that is 8. When you choose the 8, again 0 times everything will be 0 here, so we can ignore this part. 30 minus 28 is 2 times 3 will be 6. This is determinant of A, which is equal to the determinant of A transpose. Therefore we need the determinant of A times determinant of A transpose. This is what we need, which is equal to, this is exponent, 6 multiplied with 6, that is 36. The answer is B. Next question. Here there are two matrices, both of them are 3 by 3, and A inverse, it says. The A and the A inverse are given. So what are the values of X and Y, it says. So what to do now? Again, like that of the previous question, what we did, A times A inverse, obviously it must be identity. But the identity matrix for 3 by 3, you know, it's 0 1 0 0, 0 1 0, and 0 0 1. So let's apply that rule. The A is given 0 x 0, 1 negative 1 1, 0 y negative 1, which will be multiplied with 1 1 1, 3 0 0, 2 0 negative 1. This is equal to the product. It has to be 1 0 0 identity, 0 1 0, and 0 0 1. Since they are inverse each other, the product has to be identity. Okay, let us multiply and let's try to make it shorter, the product. You know, first row will multiply first column, so 0 times 1 0, and x times 3x, just only 3x remain, because 0 times 1 is 0 and 0 times 2 also 0. The same way the second column, 0 0, everything will be 0, and the next 0 times 1 0, again everything will be 0 here also. Remember, don't forget, here it is equal to 1 0 0, 0 1 0, and 0 0 1. This time try to observe without multiplying the other. Try to observe the first entry left side, it has to be the first entry to the right side, so that 3x must be 1, so x is equal to 1 over 3. That must be the answer, the x value. Which choice containing that? Choice D. Without doing the other, you have the clue, you know the answer here. From the beginning you can get the answer. But if you want to know the y value, you can proceed the last row, you can multiply the last row with the first column and get it here. The last entry will get it, I mean the third row and the first column you'll get it. Okay, 0 times 1, you know, 0, and y times 3, again 3y. And yeah, let's multiply it properly. Okay, 0 times 1 0, and y times 3 will be 3y, and negative 1 times 2 will be negative 2, and there will be entries here I can ignore. So this entry, it has to be equal to the last entry here. That means 3y minus 2 is equal to 0. When you shift it, 3y is equal to 2. When you divide both sides by 2, y must be is equal to 2 over 3. It is there, D. Okay, next question. If M is what you see here, a matrix 3 by 3 given, and A transpose times M is equal to 2 times I, and where A is a 3 by 3 matrix and I is identity of order 3, then what is the value of determinant of A? We are looking for the determinant of A. What's given? A transpose times M is equal to 2I. The M is already given. This time I can take both sides determinant. The left hand side, when we separate or when we decompose it, it will be the determinant of A transpose times the determinant of M, which is equal to the right side, the constant will be 2 cube, because order 3, times the determinant of the identity. Don't forget, determinant of identity for any square matrix will be just 1. So the determinant of A, we don't know, or A transpose and A are the same. Again, A transpose, determinant of A transpose and the A are the same. So we will get the A transpose from here means we are getting the determinant of the A. So I can divide both sides by determinant of M to get the A transpose determinant. So determinant of A transpose, which is the same as determinant of A, will be 2 cube is 8 over determinant of M, because determinant of I is 1. So let's get determinant of M. The determinant of M from the given first entry is 0, so we can ignore, minus 1 times, I can say, the second entry. I'm going to select the first row. First entry is 0, so 0 times whatever is 0, and then I show the second, the next one, negative 1 times. So I'll cancel second column and first row. 3 times 4, 12, minus 5 times 0, it's 0, so that's simply 12. Alright, then plus 2 times the last entry, cancel the last column in the first row, and 3 times 2 will be 6, minus 5 times negative 1 is negative 5, which is plus 5. So negative 12, 6 plus 5, 11 times 2 will be 22. So this is going to be 10, determinant of M. Therefore, our answer will be 8 over 10 means 0.8, or 4 over 5. The answer is C. Next question. Here it is system of linear equation, and the coefficient matrix are given here, the coefficients, and the determinant of the coefficient matrix already given. Okay, that means the D, by Cramer's rules, the D is negative 5. And then what is the value of x? We are looking for x, but x is equal to dx over d. We have the d already. Let's find the dx. The dx means we'll take the determinant of the first column will be replaced by the constant, negative 5, 5, and 0. When you are calculating the dx, first column will be replaced by the constants, and the rest column will be taken as it is. 2, 1, 0, beta 3, 1. Let's calculate this determinant. This means the first entry is negative 5 times, I'll cancel first row and first column, so 1 times 1 minus 0, which is 1, minus 2 times second column will be cancelled, 5, just only 5, plus beta times 0, because when you are taking the third column in the first row, it will be 0 times 5 times 0 minus 0 times 1, which will be 0 everything. So what remain here? Negative 5 minus 10, which will be negative 15. This is dx. We have dx from here. Therefore, the answer will be negative 15 over negative 5. That's going to be 3. So the x value must be 3, which is A. The last question, what I say, suppose a matrix A 2 by 2 given, and x is also a 2 by 2 matrix. So we can say let x be any 2 by 2 matrix A, B, C, D. And then what's given? Ax minus A transpose is equal to 2A. From this we can find Ax is equal to 2A plus A transpose. So what is A? 1, 2, 2, 3 times. What about x? We can make it capital X because bigger, and we just take it, we assume x is equal to ABCD, so times ABCD is equal to 2 times A means I will multiply every entry of the matrix A, which is 2, 4, 4, 6, plus A transpose. First row will be first column, this first row will be first column 1, 2, and second row will be second column 2, 3. Therefore let's multiply. When you multiply it, let us use our space wisely. Therefore when you multiply, what will happen? The first row will multiply the first column. So 1 times A is A, and 2 times C will be 2C. So here it is, first in 3. Again the same way, 1 times B, B, and 2 times D will be 2D. Here it is. And the same way it goes. The second row will multiply the first column, 2 times A to A, and 3 times C, 3C. And then, and the right side I will add correspondingly each in 3. 2 plus 1, 3, and 4 plus 2 will be 6. Okay, then let's equalize the first row here. It has to be equal to the first row here correspondingly. Let's do it and simultaneously. The first one, it is A plus 2C is equal to 3, and 2A plus 3C is equal to 6. I can multiply the first row by 2. When you multiply by 2, it will be 2A plus 4C is equal to 6. So I can subtract now. When I subtract, C is equal to 0. Okay, which entry containing C0? Like the C place is here, it is. Which choice containing the D? The answer must be D, but we can check the other. Then once you have the C, substitute in the first equation here, the C place. When you insert here in place of C0, what remain? Bring the 0, 2 times 0, 0, so A must be 3. Where is the A place? The first one, 3. Yes, it is correct. And go on for the next one. B plus 2D is equal to 6, and 2B plus 3D is equal to 9. And then multiply the first row here by 2. When you multiply, 2B plus 4D is equal to 12. And then subtract, D is equal to 3. The D means the last entry here. It is 3, correct. Still the D is correct answer. And then once you have the D value 3, substitute in the first equation here. 3 times 2, 6. So B plus 6 is equal to 6 means B must be equal to 0. That's correct. The B place is here. So the answer is D. So these are some of selected past paper exam questions on matrices and determinant. Hopefully I'll get back with additional questions. Thank you.